Back a long time ago, in your days in Algebra 1, you were introduced to a very important topic, the slope of a line. And probably when you studied this topic, you had no idea of its importance and how it was going to impact your future study of mathematics. Well, now we're going to kind of get an insight into the power of the slope and how to calculate the slope. And let's do so by just thinking about a horizontal and vertical axis here, where the horizontal axis is time in hours, let's say, and the vertical axis is distance in miles. And let's suppose you go out for a walk, and you walk according to this curve right here, this little line. See? So this line represents your distance. You have, after 1 hour, you've gone 1 mile. After 2 hours, you've gone 2 miles. So that you have this point out here, 2, hour is 2, and mile is 2, and then you've got 0, 0. So in 2 hours, you walk 2 miles. And if someone were to ask you, well, what was your velocity? How fast were you walking? Well, you don't need any special insight into mathematics to know, well, in 2 hours I walked 2 miles. I was walking a mile an hour. But if you think about it, you can answer that same question by, being a little more methodical. Calculate the slope. Take the change in distance, 2 minus 0, see? Change in distance, 2 minus 0, over the change in time. See? Difference of the y's over the difference of the x's. Change in, rise over run. So you get 2 over 2, which equals 1. So you were going 1 mile an hour. So notice this, that this rise over run, the change in the y component over the change in the x component, that's how you calculate slope. But notice that's also how you could calculate velocity, right? See how you could calculate velocity? Now let's suppose we walked a little faster. Let's suppose that instead of going 2 miles in this 2-hour period, we went 4 miles. So we ended up here. So in other words, this is our curve. Instead of this one modeling our distance, this is our model. So we've got 2, 4. Now notice it's steeper. But we still calculate the slope the same way. We take the change of the y's. I'm calling it y because we're used to thinking of the vertical axis as y, over the change in the x's. And we get 4 over 2, which is 2. So we get 2 miles an hour. Here's my point. Notice that what we're doing is calculating slope, but you could also think about it as the rate of change, the rate at which your distance is changing. Okay? So the slope, in this case, the rate of change of distance, which is velocity. See? Now let's look at a little bit more complicated situation. Here, notice we were walking at a steady rate throughout. In one case, 1 mile an hour. Another case, 2 miles an hour. But look at this one right here. We start off at our starting position and we walk to 3, negative 3. Now, let's think about what this means. Let's go ahead and get the slope of this. So the slope is going to be the change in the y's over a change in the x's. And what we get is negative 1. So notice over here we had a positive 1 for the slope, and over here we had a negative 1. Well, what does that mean? In other words, the steepness is the same, but one has a negative 1 slope and one has a positive 1 slope. Well, if you think about our distance application here, this would represent the direction we're going. It's sort of like if you're going forward away from a starting point, you've got 1 mile an hour. Then if you kick it in reverse and you're going backwards, your velocity could be your speed might be the same, but you're going the opposite direction. So this negative 1 indicates a direction. So the steepness is the same. This is 1. This is negative 1. So here it looks like we're going in a different direction. Okay? Now, look at this one. But the point is, remember, we're just calculating slope here. But we're learning this, that slope can give us not just how fast we're going, but in the direction. Okay? Now, look at this. From hour 3 to hour 5, apparently our distance didn't change at all. See? The distance isn't changing. Remember, the vertical axis is distance. So we were just constant. Now, what does that look like with slope? Well, we go change in y's, -3 minus a -3 over 5 minus 3. And you, of course, get 0. See? So we were 0 there. Our distance wasn't changing. Our velocity was 0. We were stopped, taking a nice rest. Then, at hour 5, we pick it up again and walk for another hour. So how does that look? Now, remember, we're calculating slope. So what we're going to do to get this slope is we're going to take -4 minus a -3, see, all over 6 minus 5. See? Change in the vertical over the change in the horizontal. And it looks like this is going to be -1 over 1, which is -1. So apparently we kicked it back into gear by going -1 mile an hour, or 1 mile an hour, but in the negative direction. Okay, now at hour 6 we turn around, and for 2 hours we go in the other direction. So let's see what that looks like. We've got change in y's, or change in the vertical. See, -4 minus 0 over 6 minus 8. And that's going to be -4 over -2, which is 2. So we go 2 miles an hour. Now notice, now we're back to positive because we're going up now. So here, let's think about this. When we have a negative slope, that indicates a direction we're going if we're talking about velocity. So if we have a positive slope, we're going a different direction than if we have negative. We're going the opposite direction. Okay? So here, we're walking away this way. We rest, continue walking in the same direction, but then turn around and we're walking the opposite direction. But the point is, it's slope that's going on. We're calculating the slope, and we're interpreting that as velocity. Now let's look at this one. Here, notice we don't have a line, okay? We don't have a line. We just have a curve. And let's suppose, in other words, it looks like what we're doing is our velocity is changing, because you notice our distance is changing at different rates, right? Up here in these graphs it was steady, 2 miles an hour, 1 mile an hour, but not here. Okay? So now our distance is being modeled by this curve. But we would still like to know how fast we're going. In particular, I would like to know how fast I was going between hour 3 and hour 7. Well, what we can do is we can talk about the average rate of change. Average rate of change. In other words, we'll talk about, in this case, our average velocity. And we're still going to do that by simply calculating a slope. So let me draw a line between these points. I've got 3, 2, and 7, 7. See? So I just draw a nice line here. And I want to get the slope of that line. And what that's going to give me, that slope is not going to give me exactly what I want. It's not going to give me, it's the best I can do. Up here, I could find out what my speed was the whole time, what my velocity was. Here, since it's changing a lot, what I can do is I can get average. So, but I'm still going to calculate the slope. I'm going to take 7 minus 2, see, change in the vertical over the change in the horizontal. And what I get is 5 over 4. So it looks like my average velocity there was 5/4 mile an hour, or 1 1/4 mile an hour. That's what we find out there. Okay? Now notice this is positive. See how that's positive? And that indicates a direction. See? So I've got this steepness, but then the fact that it's positive indicates it's going up. Now notice, just some things to point out. Over here, the line was decreasing. And notice that corresponded to a negative slope, of course, right? Here it was constant. That's 0 for a slope. Negative slope, when the curve is going up, when it's increasing from left to right, positive slope. See, positive slope. Okay? Over here, positive slope. Now this is the average rate of change. Now let's look at this one. Okay? Notice this curve, for the most part, is decreasing. It increases for a little bit, right? And then it starts to decrease. But so it looks like on average, our velocity is decreasing. Our velocity is negative on average. Okay? So let me draw a little line between here and let me get the slope. Remember, change in y's, 2 minus 5. 2 minus 5 over 9 minus 1. See? 2 minus 5 over 9 minus 1. Now let's see what that's going to be. That's going to be negative 3 over over 8. So it looks like my velocity there, because the distance is, the curve is mainly decreasing over here. Increases a little bit, mainly decreasing. The average velocity was negative. It was negative 3/8 of a mile per hour. Now, here, so we've looked at some curves, but here's what we need to realize. Let's suppose you have this function f of x, and you want to know the average rate of change on, let's say, some interval, AB. Okay? The average rate of change is going to be f of b minus f of a over b minus a. See? And that's just the slope formula, because what you're talking about is you're talking about points, right? You're talking about a point A, f of a, and b, f of b. See? And that's the slope, right? Change in y's over the change in x's. So let's look at an example here. Let's suppose we've got f of x equals x squared plus 3x plus 2. And we want this on, let's say 1, 2. On that interval. And now this is x equals 1, x equals 2. So we have a couple of points here. Now I'm not giving you the y. You can find the y. So the points we're dealing with, though, are 1 comma f of 1 and 2 comma f of 2. Those are our 2 points. See, the important thing to remember is I'm giving you the x's here, and it's up to you to calculate the y's. Okay, so let's just see. Let's see here. F of 1. Let's go ahead and calculate those. F of 1 is 1 squared plus 3 times 1 plus 2. Well, that's going to be 6, isn't it? See? Just plugging in the 1 in here. 1 plus 3. That's 4, 5, 6. Yeah. Now let's find the f of 2. Okay? So I've got 2 squared plus 3 times 2 plus 2. See? All I did was just put a 2 every place I had an x. And that's, of course, going to give me 4 plus 6 plus 2. And that's going to give me 12. Okay? So what we've got to do is we've got f of 2 minus f of 1 over 2 minus 1. Well, let me put all that in. F of 2 is 12. Minus f of 1 is 6 over 1, right? So it looks like that's just going to be 6 over 1. Yeah, there you go. There it is, 6 over 1. That's the average rate of change. That's the way we find the average rate of change.